info we already know. Okay, guys, so devices away, headphones out. Okay, so today we are going to be looking at solving systems. Oh dear. So first of all, a system, okay, is something that includes multiple variables and multiple equations. Okay, we are specifically going to be looking at systems that involve two equations and two variables. Right, up until this point, we've done a ton with solving. We've talked about the fact that we can solve for x. We can solve for x when it's an inequality symbol. Right? We can solve for y in terms of x. Right? But now when we have two variables, we're going to be able to solve and get an actual numerical value for both x and y. Okay, and there are multiple ways that we can solve for two variables when we have two equations. The first way that we can do that is to solve by graphing. Okay, my students typically agree that solving by graphing is the easiest way to solve a system. However, it comes with a couple sort of hiccups that they don't think about when we're first learning it. Okay, because you're going to see today that solving by graphing is super simple. However, it needs a couple things to happen. We need a graph. Okay, if you are just asked to solve a system and you don't have good graph paper, solving by graphing gets super obnoxious. Because then you're like trying to draw out a graph, you're trying to make it all nice and neat, and it gets really complicated. Okay, solving by graphing is also only really nice, neat, and convenient when both of them say, that's not equals, when both of them say y equals. Okay, when it's set up in a format that's easy to graph. Okay, the last thing that makes solving by graphing convenient is only when the numbers are small. Okay, it is not fun to graph y equals 452 over 375x minus 1,473. I mean, that's just not realistic, right? Our graphs would be ridiculously stupid. Okay, so graphing is going to seem nice, neat, and easy today, but keep in mind that I'm keeping you in this sort of nice, neat box of these things happening. So don't just mentally decide, oh, I'm just always going to solve by graphing because this is really easy. Okay, there are going to be times that graphing is great, but there are also going to be times that graphing is not. Okay. When we are solving by graphing, there are three things that can happen. Option number one is that we can solve by graphing and get intersecting lines. What does the word intersecting mean?
It goes through another line.
Right? Lines that cross. Okay, so if we're getting intersecting lines, that means we're getting lines that look in some way, shape, or form like this, right? They have this point that they intersect. Okay, when we get intersecting lines, our solution or our answer is going to be the point where they cross. Okay, maybe I should say that that's our answer. Okay, when we're solving by graphing and we get intersecting lines, our answer or our solution will be to name the point where they intersect. Okay, option number 2 is that we could graph and we can get parallel lines. What are parallel lines?
Lines that don't cross.
Right, lines that don't cross. Okay, so if this situation, right, we'll get lines that do this. If we get parallel lines, right, there's no point to name because they don't ever cross. So our answer will be no solution. I don't know why I'm writing in like hills today. I'm not sure what's going on with that.
There's actually a thing with that.
Right, what does that mean? I know I've heard like
If you write crooked, then you're like upset that day.
oh, maybe I'm upset. Deeper meaning.
Like if you write.
But isn't like if you go uphill, then you're like happy, and downhill? I don't know what like this means. Maybe it just means I have a board with no lines on it. I don't know.
It's a weird thing that it came up a couple years ago.
Yeah. Third option, which is the last thing we're going to write before we actually look at the graphs. Okay, our third option is that we could graph 2 lines and we could get the same line. Now this often throws my students off because they'll say, oh, I thought that was going to be perpendicular lines. Because remember, perpendicular lines intersect. Okay, so that still falls in category 1. Okay, what this means is that I graph a line, okay, and it goes here. And then I graph my second line, and it falls right on top of it. Okay, 2 lines that actually, or 2 equations maybe I should say, that actually represent the same line are always touching. So they're going to have an infinite number of solutions. Answer. Okay, so they'll have infinite many solutions. You can just write down IMS for this. Infinite solutions, infinite many solutions. There's so many of them, we could not write them all down. Okay? So here's how this actually works. So let's look at the first graph that you glued into your thing. And then I'll look here. Okay, and let's say we want to solve y equals 2x. I'm going to go into a new page here so this is clear. Okay, we're going to solve the system. Y equals 2x plus 4. And y equals negative x plus 7. So if we look at y equals 2x plus 4 and y equals negative x plus 7, do we agree that we have 2 equations, okay, and we have 2 variables, an x and a y? Okay, to solve by graphing, we're going to graph both equations on the same coordinate plane. Okay, so we're going to pretend that it's just like when you walked in the door this morning before you even thought about a system, and you're asked to graph y equals 2x plus 4. Okay, we know that we can graph y equals 2x plus 4 by finding m and b. What does m equal? 2. What does b equal? 4. Okay, so we're going to go on our first graph, and we're going to start at 4 on the y-axis. And then from there, we're going to go up 2 over 1. Okay, so from here, we're going to go up 2 over 1. Up 2 over 1. Up 2 over 1. What else could we maybe do to continue this line? Just like we talked about in the POD. What else can I do? Down 2 over 1. Okay, so my students always say, Mrs. McKinney, how many points do I need to make?
As many as you can.
I don't have an answer to that. The answer to that question is that you need to make enough of them. Okay, that might mean making enough points that goes all the way across the grid. Okay, that might be enough points to find the intersection. When in doubt, make as many points as you can. If you don't know, just make as many as will fit. I mean, it's kind of a little bit obnoxious, but it's not like it takes 5 hours to do. Okay, put as many points as you can to fit across the graph. And here's our first line. Over there. Okay, and at this point it looks just like what we did in the POD, right? Now we're just going to kind of pretend that that graph isn't there. Just ignore it for a moment and look at the second equation. Okay, what does m equal? Negative 1. What does b equal? 7. Okay, so we said that we're looking for one of 3 things to happen. We're looking to see if when we graph this, it intersects with the other line. We're looking to see if it is parallel to this line, or we're looking to see if it's actually the exact same line. Hopefully we recognize this will not be the exact same line because it has different info. Okay, but we'll start sort of graphing here to see what happens. So where are we going to start? At 7. Okay, so we're going to go to 7. 1, 2, 3, 4, 5, 6, 7.
What if you can't get 7 on your graph?
Do what?
What if you can't get 7 on your graph?
Okay, get 7 on the graph. Go one above it if you need. You might have to move that up a line and then draw up above. Okay, now what's our slope? How do we do a slope of negative 1?
Start at negative 1. No. Start at negative. Start at 7.
And then do what?
Go down 1, right 1. Yes.
Okay, we don't need to make any more points because that was enough points, that's enough info to tell us which of the 3 situations we're in. Right, if I graph this line right here, are those intersecting lines, parallel lines, or the same line?
Intersecting.
Right, do we agree that these are intersecting lines? Okay, they intersect at this point right here. Okay, and we said if we got intersecting lines, then we would name that intersecting point. So now we're going to name this point, this is the point, +1, +6.
Can we just like put it on the graph?
Right. So, I mean, in Alex, there'll be a specific place for you to write it. If it's like your final exam, there'll be a blank for you to write it. But yeah, it's just not ordered paired. Okay, this tells us x equals 1 and y equals 6. Okay, so when x equals 1 and when y equals 6, these two equations are both true at the same time. Okay? So let's look at another one. Okay, we have two equations and we have two variables, which means this is a system. Okay, one of the ways that we can solve a system is by graphing. So let's start with this first one, right? We're ignoring that this is even here. Pretend it's not. Where are we going to start? At 5. Then what are we going to do? Up 1/3. How many points am I going to make? Enough, right? Whatever that is. Yeah.
Do we start writing on the...
Yep. Yep. Do that on your second graph. Do this on your second graph. Okay, so right, my line there didn't perfectly go through all my points, but that's okay. It's not going to matter because my points are there. Okay, so now we're going to look at the second equation. Where are we going to start?
-2.
-2. Then what are we going to do? Up 1/3. And so I'm going to do that a couple times. I haven't touched the other line yet. Still haven't touched the other line. Am I ever going to touch the other line? No, right? Because this line has the same slope, they're the same steepness. What did we say our answer would be if they never crossed?
No solution?
No solution, right? They're parallel lines, and the answer to parallel lines is no solution. This doesn't have an answer. There isn't an x and y value that will make this true. Are we okay on that one? Now let's go to our third graph. Okay, so we have two equations.
I was gonna say something about
Yeah, we have two equations and we have two variables. So it's a system. So let's try and solve this by graphing. Where are we going to start on this first one?
-3.
-3. Then what are we going to do?
Up to
2 over 1. 2 over 1. How many points are we going to make?
All of them.
Right? The annoying amount. How about this second equation? What are your thoughts on that, Lily?
Don't you have to divide by 3?
Yeah, this isn't in that nice, neat form that we need it to be in, right? This doesn't look like slope-intercept form. So if we want to make this into the nice, neat form, we have to solve this for y. Okay, and to solve this for y, we need to get y by itself. Okay, and thankfully this is a nice, easy one to solve. If it's not nice and easy to solve, it's usually not worth it to do graphing. Okay, so what do we notice now, Lily?
It's infinite many solutions.
This looks exactly the same as the other one. So if I go to graph this, it's exactly the same as the other one. So we have IMS. Okay, if we can get materials